This is Mr. Masonette, and what we're going to do today is we are going to explore something called Pix Theorem, which is just an alternative way to find the area of a polygon. The formula right here represents Pix Theorem, and we have two variables within our formula. The variable I in our formula represents the number of points that lie directly on intersecting lines found within the borders of our polygon, and B will represent the number of points that lie on intersecting lines that are directly on the border of our polygon. So once we figure out what the value of I is and the value of B is, we can substitute those values and then solve this equation, and that will give us the area of our polygon. So let's start with the variable I and figure out how many points we can find within the borders of our polygon. Now, if we look inside our polygon, we just have to figure out where we see a vertical line intersecting with the horizontal line. So we would say that there is a point right here because we have two lines intersecting each other. So that's one point located within the boundaries of our polygon. Here's a second and a third, and we can keep going until we find all points found within the boundaries of our polygon. And because this takes quite a while, I'm just going to speed this up so we can hurry up and get a total of these points located on the inside of our polygon. Now that we have found all of the points located within the boundaries of our polygon, let's count them and figure out how many we have altogether. We have 4 here, plus 5 here, which is 9, plus 5 more, which is 14, plus 5 more, which is 19, plus 4 more, which is 23, plus 3 more is 26, 3 more is 29, 3 more is 32, and 2 more is 34. So we have determined that our I value will be equal to 34. Now let's figure out how many points lie directly on the boundary of our polygon. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now be careful, you cannot count this line right here because there's not a horizontal line intersecting with this vertical line. So we got to skip over this line and go right here because we do have intersecting lines right here. So this would be the 14th point. And then we have to go all the way here to get the 15th point, 16, 17, 18, 19, 20, 21, and 22. So we have 22 points located directly on top of the boundary line of our polygon. So we have determined that B is equal to 22. Now that we have our two values, let's plug them inside our equation and see what we come up with. First, let's take I and substitute that with 34. And then we're going to bring down our plus sign and substitute B with 22. And we have to divide that by 2 and then subtract 1. Now remember, you have to follow the order of operations when solving expressions. So we have to do the division portion of this equation before we add or subtract. So let's simplify this to be 34 plus 11, because 22 divided by 2 is 11, minus 1. 34 plus 11 is 45, and 45 take away 1 is equal to 44. So by using Pix Theorem, we have determined that the area of this polygon is 44 square units. Now let's use a different strategy just to see if we come up with 44 square units. Now, most of the time, teachers will say, take this polygon and divide it into recognizable shapes. So what I did is I broke this polygon into 3 shapes, a rectangle, a triangle, and a trapezoid. Now, the area of a rectangle is length times width. The area of a triangle is determined by base multiplied by its height divided by 2. And a trapezoid is determined by adding the two bases, b sub 1 and b sub 2, dividing that by 2, and then taking that total and multiplying it by the height of the trapezoid. So let's start with this rectangle. This rectangle has a length of 4 and a width of 8. And 4 times 8 is equal to 32 square units. Now the triangle over here has a base of 1, 2, 3, 4, and a height of 2. So the base is 4, the height is 2, and we have to take that product and divide it by 2. 4 times 2 is 8, and 8 divided by 2 is 4. So the area of the triangle is 4 square units. To figure out the values of b sub 1 and b sub 2 in a trapezoid, really you're just figuring out the lengths of the two lines that are parallel to each other in the trapezoid. As you see here, this line and this line in our trapezoid are parallel to each other, so we would consider those two lines b sub 1 and b sub 2, or the two bases. If we take a look at the length of this line, from here to here, it would be 1, 2, 3, 4, 5, 6. So I'm going to substitute b sub 1 with 6 and add that to the line that is parallel to it, which has a distance of 2. And then we have to take that total and divide it by 2. And after that, we have to multiply it by the height of the trapezoid. And the height of a trapezoid is determined by the distance between the two parallel lines. So if we were to take this line segment and measure it, it would have a distance of 2. So let's substitute the height with a value of 2. Now we have to take 6 plus 2, which is 8, and 8 divided by 2 is 4. Now we're going to take 4 and multiply that by 2, and that gives us an area of 8 square units. Now let's add all of these areas together. 32 plus 8 is 40, plus 4 more is 44. So we would say that this polygon has a combined area of 44 square units, which is the same answer that we got when we applied Pix Theorem.